All right, section 2.5, using linear models. This is why we did the project that we just did. Now that you remember, hopefully, what you did in Algebra 1, you can hopefully be able to handle section 5 without any problem at all. It deals with scatter plots and placing trend lines and predicting future events using that trend line, which is something that's going to happen in this class a lot. So you got to be good at it. Take a look at what we have sitting here. The graph shows the number of hours and the amount of money you earned each day last week. How many hours should you work to earn $200 based on what you see in this graph? What do you think? Maybe 9 hours? Why? So you want to put a trend line in there already? Okay. So it seems like the more hours you work, what will be true? Yeah, I would hope so, right? If I'm putting more and more hours in, I better not be making less and less money. True? Yeah, so the more hours you work, the more money you make. And it seems like this might be a linear situation, okay? So we draw a trend line in there. And you just kind of pick a reasonable location for that trend line. Does the trend line have to go through every single dot? Nope. You want it to be close to all the dots, though, as close as possible to all the dots. So maybe this is my line that I put in. That seems pretty reasonable. Based on that line now, I can answer these questions. What assumptions did you make to find your answer? Well, I'm assuming that the more hours you work, the more money you make. That's what allows me to draw a trend line in there with a positive slope. Okay? Now to answer the problem, I would follow my trend line up until about $200, which would be where? Yeah, because now you look at the scale and you say, okay, 60, 100, that must be 80. 120, 140, 160, 180. This is 200 right here. So if I want to make $200, I'm going to now go over to where my trend line is and then go down to tell me how many hours I need to work. So based on the line that I drew, looks like I got to work about 8.5 hours to make $200. It's actually a pretty good deal, I think. Wish I made $200 the amount of work that I work every day. Anyway. The line that you drew, maybe it's a little shallower than my line, and your line comes across over here, and it shows that you need to work about 9 hours. Or maybe somebody else drew another line, and it was a little steeper, and it looks like about 8 hours will give you $200. Okay? That's the idea, and that goes back to the project. We had, 5 groups, and all 5 groups came up with different equations, which gave them different results when they were trying to predict that future event. Because we all had different lines that we drew in there. Right? Okay, thank you. So that's the idea in this section. So, right off the bat in this section, describe the correlation in these plots. What do you see? That's what correlation means. What is the trend? This is negative. If I draw a trend line in here, I'm going to draw it in a negative fashion. So therefore, the correlation is negative. What about the next one? If I draw a line in here on this one, it will also have a negative slope. You want to argue that?
Yeah, because all the points are out there. So say with the last one, it's your wages to your time work.
Yeah.
If you were getting paid different amounts for every long job, say you were getting paid $10 for one, but it took you 10 minutes to do, and you got paid 50, but it only took you 5 minutes to do.
Yeah. What are you arguing? The line I just drew on this one, based on the data that I see in this scatter plot, it most certainly is. Now, look at the difference between these two. Both of these are negative. I think what you're trying to say is what I'm about to say. Look at this one compared to this one. What can you say? Yeah, this one has dots that are more spread out. This one has dots that are more closely related to that line than I have, okay? So instead of just correlation being negative, we can say that this one is strong and this one is weak. Or at least weaker than the other one is. You can use those words to describe how good a correlation you're looking at. I think that's what he was getting at. How about the fourth one? Yeah, if I'm drawing a line in there, that looks positive. So that might be it there. How about the last one? Also positive. If I'm drawing a line in, that's probably it there. So this is positive and positive. Now, using the words strong and weak, which one would the one on the far right be compared to the other one? Strong. And this one would be weak. Those words only apply if you're comparing two different scatter plots like we are right now. This one is stronger looking than this one is. So that's why I can call this one strong and this one weak. If I have a scatter plot on its own with nothing to compare it to, though, I can't really say strong or weak because I don't know. I could change the scale and make it look strong. I could change the scale on this one over here and make it look weak. But what I can't do is fudge the fact that it's a negative correlation or a positive correlation. So just be careful with these words. How about this one in the middle? There is no correlation here. There's no line that I could put in that makes sense based on the data that I see. Like these are clearly strong, positive or negative correlation. In this case, if I draw a line in like that, it seems like I'm kind of matching up with some of the dots, but not some of the others. I could draw a line in like this, and the same thing would be true. I could draw a line in like this, and the same thing would be true. If you can't find that correlation by drawing your trend line in there, then there probably is no correlation. Two things that are not correlated would be like the height of the table in people's living rooms or dining rooms compared to intelligence. There's no correlation there. Some people have very short tables, some people have very tall tables. Why would somebody have tall tables? Because they're tall. Yeah, it has nothing to do with intelligence. So the vocabulary we need to know. Scatterplot is a graph that relates two sets of data by plotting the data as ordered pairs. You're plotting ordered pairs. You're not connecting the dots. That's not what you do with a scatter plot. You never connect dots. You can draw lines to represent the data, but you cannot connect dots. Correlation is the strength of a relationship. So by negative, how do I know this is negative? Why did I call it negative? Because if you were to write the equation for the line, the slope would be negative. If you were to write the equation for this line, the slope would be positive. That's why it's called positive or negative. Correlation is the strength of that relationship. That's why I'm calling this one strong compared to this one. This one's weak. This one here is strong. This one over here is weak when they are compared to each other. The strength of a relationship. The stronger the relationship in the data, the stronger the positive or negative correlation. But something is not strong or weak on its own. The table shows the number of hours students spend on video games the day before a test and the score that they got on that test. We want to make a scatter plot of this, and we want to describe the correlation. Before we do that, what do you think the correlation is going to be? Let's say that in a sentence. The more time students spent on video games, what? The lower their test score, okay? So that would give us what type of correlation? A negative correlation. Good. All right, so let's come up with what will go on our graph and where. What do we do first? And where should my axes go? This corner. Because I don't have any negative hours spent and I don't have any negative test scores. Although I think some people would enjoy making a negative test score. What goes on the x-axis? I'm asking what is the independent variable, right? What drives the other one? The more you play video games, the more your test score will change. So this is hours spent, which makes this one test score. Now we need to come up with a scale that will work. So let's look at hours spent. I think there's 14 lines here. We need to make it from 0 to 5. Every 2? Okay. So every other one is 1. So here's 1, 2, 3, 4, 5. I didn't make it all the way across, but that's fine. I spread it out as much as I could. Now I need test scores. We have 14 lines. We need to go all the way to 100. Our lowest score might be 60. Every 2 is 10%. That takes me up to 50%. All right, so you were trying to do this. That is dangerous to do. The reason why that's dangerous is because you have this whole thing right here that gets chopped off, right? If I'm chopping this off here, it's easy to draw a line in and then say that that's my x-intercept if I'm looking for my x-intercept. What's wrong with that? What? Yeah, this line doesn't actually extend like that anymore because you've chopped from 60 all the way to 0. If you were to extend this back out, stretch it back out, what you would see on that line that you drew was this. And that's not what is actually happening here. This is supposed to continue on out there. So be very careful. I actually do not recommend doing that ever. Unless you really are sure that you are not going to need this point out here or this point out here, then don't do that, okay? Come up with a scale where you have 0, 0 until you're comfortable with what it is that you're doing. So go by tens. We have 0, 0 sitting here, 10, 20, 30, 40, here's 50, 60, 70, 80, 90, here's 100. Breaking the graph is dangerous. Okay, now what should we do? Yeah, just plot the points. So I'll change colors since I'm tired of blue. And I have 0, 100. I have 0, 94. We're just kind of estimating here. I have 1 and 98. I have 1 and 88. Then I have 1.5. So that was a pretty smart scale we used. And 92. Then I have 1.75 and 89. Then I have 2 and 75 and 2 and 70. Then 3 and 78. There's always going to be that one that throws everything off. Then there's 4 and 72. 4.5 and 57. 5 and 60. There's all my dots. Does it look like there might be a correlation here? Most definitely. And I can do the same thing, and I have done the same thing with missing homework assignments and test scores. And guess what correlation I see? The more missing homework assignments, the lower the test scores. It's that simple. I can do that with this chapter, and it will be the same. So can I draw a line in here? Could I draw a line if it asked me to? Yes, I probably could. Does it ask me to? No, it asks me to do what? Describe the correlation. So what is the correlation here? It's negative. I can't really say strong because I have nothing to compare it to. I can calculate whether or not it's a strong or weak relationship, but we don't know that how to do that yet. I don't have anything to compare it to, so all I can say is negative here. All right, the table shows the median home prices in Florida. What does median mean? No, it does not mean average. Middle. Who said that? It is the middle value of a set of data. So like the median score on a test, if I took everybody's tests and lined them out from lowest score to highest score, and then I started picking off the high and the low each time, eventually I'd get down to the middle score. That's the median. So we have median home prices in Florida. What is the equation of a trend line that models a relationship between time and home prices? Use the equation to predict the median home price in 2020. So now we are going to write an equation, and then we're going to predict the median home price in 2020. How do we do this? Eventually. Got to find the slope of the trend line that they put in here. How do I do that? Pick two coordinates. So you want to find two ordered pairs on this that are good for this line. You remember this? When have you done this before? How about yesterday? Right? Or last night on the homework assignment. You've done this. The way that you do this properly is you pick two ordered pairs on the equation. Should I pick two ordered pairs that are super close together, like here and here? No, why not? Yeah, remember the meter stick thing. They're way too close, okay? Your line will not be as accurate. I'm not going to get the exact value here on this line. I'm not going to get the exact value for my other ordered pair. But if I spread those two dots out far enough, then the fact that I'm off by a little bit won't hurt as badly as the fact that I'm off by a little bit with both these ordered pairs real close together. So you want to pick them separated by quite a distance, as much distance as you can. So somewhere in this region, find me an ordered pair that looks good. I heard 10, 40,000. That looks pretty good right there. I don't want to guess on something as important as the y-intercept over here. I want an ordered pair that's on the line somewhere, not somewhere as important as that. So we have 10, comma, 40,000. We need a second ordered pair. So 55 puts me like about there. $40, I can't hear what you're saying. 55 and 110, but I'm a little bit above that 110, it looks like on my graph there. Okay, so 55 and 111 then. So there's my two ordered pairs. Now that I have them, what do I do? What is that we're doing? No. You need to find the slope first. We find the slope by doing what? M equals y2 minus y1 over x2 minus x1. So let's fill in those. 111,000 minus 40,000, 55 minus 10. So we get m equals 111,000 minus 40,000. $71,000 divided by 45. I'm betting we can reduce that or even just come up with the actual number. What is that reduced to? What is it? $1,577.7. Oh, so it's just repeating 7? Okay. So 1,577.77. Or 78, if we're repeating, I guess. So 0.78. And what is that? That's the slope, but what does it mean? That is, every year, the price of the house goes up by. So what would the units on this be? Dollars per year. Dollars per year. Good. It's important, like I said, that you understand what that slope actually is representing. Your change every year, okay? Now that we have the slope, what can we do? Point slope form. So I'm going to write y minus. So pick a ordered pair. This one seems to have easier numbers. So I'm going to write y minus 40,000 equals 15,000 or 1,577.78 parentheses x minus 10. So that is the equation, but we want to put this in what? That is point slope form. Slope intercept form. Simplified down to slope intercept form. So we have y minus 40,000 equals 1,577.78 x minus 15,777.80. Now what? Simplify. Okay, so what does that mean? Add 40,000 to both sides. We get y equals $1,577.78 per year x. What? Plus. No, 24,222. Point. Is that it? Yeah, okay. So there's your equation. Take a look at that y-intercept. How does it compare to the graph? Looks close. Okay, that's why I said don't pick the y-intercept unless you specifically know that it is going through something in particular. We don't specifically know that one. We want to pick 2 points that are in our data. We'll wind up with a different y-intercept, but it'll be close. Okay, so there's the equation. It says write the equation, so we did. And then it says use the equation to predict the median home price in 2020. So what will we do? So substitute in 2020 into that equation. Good. Very good. I didn't bring that up specifically to make that mistake when we got to this point. What years are we using here? But this isn't year 10, year 20, year 30. This is after 1940. You have to see that. So how many years is it since 1940 if we're talking about 2020? 80 years. So we're going to plug 80 in. If you were to plug 2020 in, you get some ridiculous number in the billions or something like that. It wouldn't make any sense. So we need to plug in 80. So stick 80 in for x, and then multiply 1577.78 times 80 plus $24,222.20. What do we get? Plug in 80 into the equation. What do you get? $150,445. Finish off the problem. In 2020. That's the answer. So first of all, you can make a scatter plot. Second, you can put your axes on there and your scale, then make your scatter plot, then put your line in there, then pick two dots that are on the line but far apart. Then you can find your slope, then you can make your equation. Once you have your equation, then you can predict what they're asking you to predict. There's a lot going on in these problems. They do take time, but you can do them. So, now that we've learned all that stuff, we want to apply the line of best fit, meaning we want the calculator to come up with our information for us. Use the graphing calculator's regression feature in case you forget what that was called. Once we press menu, it's regression that you're looking for to find the equation for the line of best fit for the following data. So that means what we're going to do is we're going to go back to our calculator, and you have an option of either deleting what you just did, meaning clear the memory, start all over, or you can start a brand new spreadsheet. Either one is fine. You research the average cost of whole milk for several recent years to look for trends. The table shows your data. You got years, 1998 through 2008. Average cost for 1 gallon of milk looks like it goes from $2.65 to $3.77. We want to enter this data into our spreadsheet in our calculator. Then based on the linear model that we come up with, that the calculator comes up with, how much would you expect to pay for a gallon of whole milk in 2015? So let me go to my calculator. And I want the spreadsheet, so I go to the spreadsheet. And I want to call out my variables. My variables are going to be what? Year. By the way, on the calculator, you do need to type in a word up here. I think 2 letters will work, but I think it gets upset with 1 letter. So you want to just come up with a word. And then my other variable will be what? So how about cost? Just something that makes sense for the problem. Skip over the gray line. We will not type anything in there. We're just going to enter our data in. Now you have 2 choices here. You can go with 1998, 2000, 2002, 2004. Yes, you instead can go years since. So let me do that on here. Instead of year, I'm going to go with years since. What that does is it reduces down the numbers that I'm going to get. I'm not going to have enormous y-intercepts or slopes. It keeps my numbers simple. So if I call 1998 year 0, then 2000 would be 2. 2002 would be 4. 2004 would be 6, and then 8, and then 10. That makes my numbers easier. You could do it that way. Or you could say years since, so this would be 1998. Or you could say years since 1990. And then that would change this to an 8, a 10, a 12, and so on. Okay? You don't have to go with the years that they give you. You can call out some year as your year 0 and then go from there. So we're going to go with 0, 2, 4, 6, 8, and 10. Let me bring up my calculator. And now I can enter that data in. I have year 0. 2, 4, 6, 8, and 10. Go back up, and now I enter in the data that they give me. 2.65, 2.89, 3.00, so just 3, 3.01. Year 8 would be 3.2, and finally 3.77. Once you've entered all that stuff in, press home, move over 1 to data and statistics, press enter, and all of your data is there in a completely disorganized fashion. Move your mouse down to add a variable here, click, and what will go on my x-axis? Years. As years go on, the cost changes. So years goes on the x-axis. That organizes my data for me. And then I go over to the y-axis. My other variable was cost. What do we do now? Menu. We want to put that trend line in there. Menu, analyze. Regression is number 6. Y equals mx plus b is the format we want that equation shown in. So I click on that, and it gives me my equation of y equals, no. I haven't found it. It would be nice, wouldn't it? It doesn't matter anyway because you have to evaluate it. So we have our equation here of that. Write that down in your note packet. Then you can go back and figure out what the answer is going to be. So let me get rid of the computer, or the calculator here. Goodbye. And what was the equation? (0.093429x) and then plus 2.61952. Normally you'd round, usually to like the nearest hundredth, but we're writing all that down because it's easy to do. Based on the linear model, how would you expect to pay? How much would you expect to pay for a gallon of whole milk in 2015? What am I going to do? Do I plug in 15? I plug in 17 because 2015 is 17 years since 1998, which is how I defined my x variable. Be very careful when you do this. So I'm going to write y equals 0.093429 times what? 17 plus 2.61952. I type this into my calculator exactly the way I see it, and I get y equals what? 4.207. This is money, so I'm going to write 4.21 dollars per gallon. It's a story problem. Remember your units on the end. You want to make sure your answer makes sense. $4.21. How much does a gallon of milk cost these days? Okay, depending on where you go. But is this a reasonable price? I mean, is that kind of what we're seeing these days? More or less, yeah. Okay, so this stuff does work. This is why we do this sort of thing. Anytime you see projected data, like if you ever watch the news or anything like that, or somebody says, oh, I think by the time it gets to be about 2020, the price of for a gallon of gas is going to be about $6. They're doing what we just did here. So it's very real world that we're doing in this section. And that is all we're doing in this section. So you are now able to do the entire assignment.